Hi, and welcome to session, where are we now? 14 on tangents and normals. So there we go. Hopefully you can see my screen now. And let's start. If you can't see my screen, just let me know in the chat, but hopefully it's showing now. And if you're new here, I am Ashley from Miss IB Maths. I'm an IB examiner, tutor, teacher, and doing these collaboration or doing these bootcamp sessions in collaboration with Exam Dojo. So we're just going to be starting with a warm-up question, and then we're going to be looking into some how-tos with tangents and normals, do some worked examples, and then we'll look at some exam past paper questions and some tips for doing those exam questions and common mistakes, things like that. So to start off with, what is the gradient of each of these lines? So what is the gradient of the line parallel to y equals 2x plus 3? And what is the gradient of the line perpendicular to y equals minus 3x plus 4? Just to get you into the maths mode on this Saturday morning, let's see. Any ideas? Gradient for A and gradient for B. You can answer in the chat. All right, so gradient of a parallel line, we have y equals 2x plus 3. Parallel lines, a clue about those is they have the same gradient. So of our parallel line, it also has a gradient of 2. We can say m of the parallel line is equal to 2. And for our perpendicular line, minus 3x plus 4. If I have my line going like that, my perpendicular line is going like that. So that would be like a normal, making a 90-degree angle over there. So if my gradient of my first line is minus 3, then the gradient of my perpendicular line is the inverse reciprocal. Negative reciprocal, two words that mean the same thing. So if this is negative, then this one's going to be positive. And if that one is 3 over 1, I flip it around and it becomes 1 over 3. Positive, because that one was negative. So you just make it positive if it's negative or the other way around and then flip it over. So there we go. These are useful for tangents and normals, seeing as they often give you clues like they won't say, yes, you do need this for AISL. And welcome. So for the questions in the exam, they'll often say find the equation of the tangent parallel to this line. So you need to then recognize and know that parallel means they have the same gradient, or perpendicular means they have the negative reciprocal. Or the tangent is horizontal, so you need to know that a horizontal line has a gradient of 0. There's little clues like that. All right, so in the formula booklet, this is what you have to help you with the equations of tangents and normals. So they have 3 forms here. I'm going to highlight them in different colors because they look kind of like all one thing together. Let's do that one. So can you see there's actually 3 formulas hiding in there, not just one line. So these are all the different forms of a line. This one is gradient intercept form, because if you have a gradient and a y-intercept, then you should use this form, gradient intercept. This one over here is called standard form. And sometimes the question will say to you, leave your answer in this form. They won't say leave your answer in standard form. They'll say leave your answer in this form. So you go from this form to this form by moving everything over to one side so that you only have 0 on one side. And then you've got to multiply by whatever number to make sure that you don't have any fractions left. So Let's say if I have y equals 2x minus 3. To put this into standard form, I have to move everything over to the side. So I'll have minus 2x plus y minus 3 equals 0. I don't have any fractions, so that's all good. And generally what we like is to have positive with our leading term. It's just a preference. You don't have to. So you could change, like pretend we move it all over to the other side and make it negative. So 2x minus y plus 3 equals 0. They're exactly the same. This one just looks a little bit neater. We prefer when the leading term has a positive coefficient. So that's what they mean by standard form. So you can take any line like this and put it in standard form. And in tangents and normals, that's quite a common last step, is you'll get your equation like this or like this, and then they'll say, put it in standard form, or just like this. And then this form, this is our gradient point form. Gradient point. And this one, I think, is the easiest for finding tangents and normals because it sets you up directly to find your line. This one over here, I know some people use, you have your point, you have your gradient, but then you have to find C, and then you have to go back and write C in. If you have this one, all you need is your point and your gradient. So that's one less step than that one. And so the questions are generally leading you up for this one. So we're going to use this a lot. I'll just write it out. That's y. Sorry, I'm covering the screen. There we go. Y minus y1. So that's if we have a coordinate, x1, y1 equals mx minus x1. So all you need there is to substitute in your y1, your gradient, which you're going to find from the derivative, and your x1. So those 3 points rearrange, and you've got your line in that form. And then you can move everything over to one side for that form if they ask for it. So that's the one I'm going to be using today. If you do use this one and find the y-intercept and then go and write it, that's also fine. All right, a little bit of theory. The tangent to a curve is a line that goes through at a point. So you can pick any point on any line and make a tangent to the curve at that point. So that point will always have an x coordinate that they'll most likely give you in the test. So here we have at the point x equals 2. We can find that that's at the point, I don't know, y equals 2.5 maybe. Just guessing where that is. And the gradient is 3.60. So m is 3.60. I hope I've read that right. It's very small. So these are the 3 pieces of information that we need to find the equation of our tangent, our x1, our y1, and our gradient. So then we can use this form like this. Sorry, again, I'm probably covering it up. So from each of these, we can find our points. So y1, that was 2.5. x1, that was 2, and m was 3.60. So those are the 3 pieces that you insert, and then you can find that line. This y and this x, we leave them as y and x because we want to end up having an equation of our line in terms of x and y. So if they said maybe here, you could also have a point there, and then your tangent goes through like that. And you could find the equation of that tangent. Can you see if I pick this point here and I have a tangent at that point, it's just a flat horizontal line. And that gradient there is going to be 0. So m equals 0 at that point. That also means that our derivative equals 0 at that point. So these could be useful clues that they give us in the question. Take note that in this question, there are positive gradients. These are all positive gradients because they're all increasing functions. So that is a tangent. And why this relates to derivatives in calculus is because gradient and derivative should be in your head the same word. So whenever you hear find the gradient, I want you to think find the derivative. These words should be equal in your mind. differentiate, gradient, rate of change, differentiate, rate of change. If you hear rate of change, students often get scared off by this one. That just means gradient. These are all words that should be the same in your head. So if they say, find the gradient at a point, you think, I need to find the derivative. If they say, find the derivative, you think this is the gradient. That's just going to really help you to be able to see what different questions are asking from you, because they're going to ask it differently. But all the same words. So the gradient at this point is also the derivative at that point. So let's do an example to see what that looks like. Let's go blue. All right, so if I'm finding the equation of my tangent, remember that I need my x1 point, I need my y1 point, and I need my gradient, which is also, as we just discussed, the first derivative at that point. So often the question is going to give you that x coordinate. Very, very often they will give you a point of x. So 2, great. We don't have to do any working out there. Then you need your matching y coordinates. So you take the function you've been given and you substitute your x. So f of 2 is equal to 2 squared minus 3 times 2. So I've just taken this function and substituted in for 2, which gives me 4 minus 6, which gives me minus 2. Okay, great. I am 2/3 of the way there. Now, finally, I need to find my gradient, which I do by finding the derivative of this function. So I'm going to find the derivative, that is 2x minus 3. And you see, just from that, x squared becomes 2x, minus 3x is minus 3. There's my derivative, but I'm not finished yet. I need to substitute my value to get it to be an actual number. So I can take f dash of 2, because that's the value. 2 times 2 is minus 3, which is 2 times 2 is 4, minus 3 is 1. So my gradient is 1. And now I have all of the things that I need for this tangent, so I can write it into the formula. So then we get, let me just make this a bit smaller. Oops. Okay, so now I write that into my formula. Y minus y1 equals m x minus x1. Check no questions, no. And now I can substitute. So y and x, they're just floating. There's nothing we change for them. y1 was minus 2, minus minus, don't forget brackets. Our m was 1, that's a lovely and easy gradient. X is just floating. x1 was 2. And now we can multiply out and simplify. So that's y plus 2. 1 times x, just x. 1 times minus 2 is just minus 2. And finally, subtract 2 from both sides. So minus 2 gives us minus 4. And there we have the equation of our tangent. Can again neaten this up. Let's do... Oops, lost something there, but hopefully there, that makes it a little bit better. Where did this bracket come from? There. All right, so this is the step when we're finding the equation of the tangent. You just need to remember that you need these 3 pieces of information. Most of it is given. Once you have that, you take the original function to find the matching y, and you take a derivative function to find the gradient. And then put it into your formula and you're good. So this is a very basic standard question just to show you the method. The questions will be similar, but they'll maybe give you a clue. Instead of saying what the gradient is, you find different values, but we'll have a look at that in a moment. All right, let's look at normals. So normals are perpendicular lines to your tangents. So see this here, that was our tangent line, and if we take the normal line, it's going perpendicular, making that right angle. So the important thing to note here, really the only difference for these, is if the gradient of your tangent is something like 3, then the gradient of your normal will be -1/3. So we've added a negative and we flipped it on its head. So that was divided by 1. All numbers are divided by 1 if we want to turn them into fractions. You just got to flip it around. So let's try another one. Let's see if I have that the gradient of my tangent is 2/5. Well, then the gradient of my normal is just -5/2. If my gradient of my tangent is -75, then the gradient of my normal is 1/75. Okay, so this is just another extra step that you'll do everything the same. You'll find the gradient of your tangent, and when you get to that step, you'll flip it over and then insert it into the formula. So let's do an example with that. Any questions? No. All right, so let's write it out. Always helps to do this. Then you know what you're working with and what you're given. So x1 is x equals 2. Great. At that point, my y1, it's the same as the previous function, so that was just -2. But let me go and do that anyway, just so I'm not confusing anyone. F of 2, all right, I'll build it down. F of 2 is equal to 2 squared minus 3 times 2, which is 4 minus 6, which is -2. So we get -2 for our matching y coordinates. And then a gradient. We need to find f dash x again, which is 2x minus 3, and substitute our point of 2. This is all very similar to the last one. We're going through the same motions. This is the equation of our tangent. So again, that is 1. Now for our normal, because we're doing a normal, this is our only extra step with a normal, is I now need to flip this and add a negative. So if I flip 1/1, I just get 1/1. So it's still 1, but it becomes -1 because that one's positive, so that one must be negative. So the equation of the gradient of my normal is -1. That's the only difference with finding the equation of a normal. And let's put it into my formula. Make sure I don't cover that for anyone. So -2. My m is now -1. And my x1 was 2. So simplify, y plus 2 is -x plus 2. And then -2 from that side. If I have +2 -2, that's just 0. So it's just y equals -x. That's the equation of my normal. That's the only difference with tangents and normals. So don't be afraid of normals. Any questions at this point? Okay, let's do some exam questions. Ooh, there we go. How do I? Okay, so this is from May 2025. It's a paper 1 question for AA standard level. So no calculator if you're in AA. However, if you got this question in AI, you would be able to use a calculator. But the questions are very similar, so there's no real difference. Just AA wouldn't have a calculator, AI would. So consider the function. We have a cubic function over here where x is an element of real numbers. That part doesn't really matter to you in this question. It's just all real numbers, and that's all that we are going to be working with unless we're in AHL. So we need to find f dash of 1. By the way, I say f dash. A lot of teachers say f prime. It just depends on who taught you maths as to what you say. So excuse me if you're used to hearing f prime, which I think sounds a lot fancier than f dash, but I can't change it now. It's been too long. So f dash of 1, that means find the derivative when x equals 1. That's what they're saying there, when x is 1, and that means find the derivative. So let's go ahead and find our derivative. Don't do too many things in one step and show all stages of your working. I also recommend that you write out the question each time on top and then do your working. So actually I'm going to model the kind of things that I talk about to you. And I think this just helps with misreads, with not copying correctly and things like that. Because if you have it here and you're working from that, the examiners can see. So if you've misread or misseen or miswrote, they will see what you've written and then be able to mark from that. Whereas if you haven't and you get something wrong or see something differently, they can't tell what it is. So I always recommend writing the question. Okay, so we have 3x squared plus 10x, and that's just 0. And now we need to find at f dash of 1 when x equals 1. So let's substitute 1, which equals 3 plus 10, so 13. There we go. We found f dash 1. What they're doing here is they're, without saying the steps, they're saying that x1 is equal to 1 in this question, because we're going to find the equation of the tangent. So remember, you can set up your x1, y1, and your gradient so that you know what you're found and what you're finding. So here, that was a sneaky way of saying at the point x equals 1. Okay, we've got that. Now, what have we calculated here? F dash of 1. Well, that's just the gradient. Our gradient is now 13. So they made us find the gradient and then substitute. So they did that all in one step. So just watch out for that. What they've done there is given us that's f dash of 1 is same as the gradient. And now to find the equation of the tangent at x equals 1, the only missing thing there is to find our corresponding y coordinate. So if I just write my function, f of x equals x cubed plus 5x squared. Remember, to find the y coordinate, we're taking the original function, not the derivative. I see students getting confused with that a lot because we're finding a point on this graph, not on the derivative graph. So then I want, when x is 1, I want to find my y. So 1 cubed plus 5, 1 squared plus minus 8, sorry. So that is 1 plus 5 minus 8, which is 6 minus 8, which is minus 2. All right, there we go. Now we have all of our information that we need to find the equation of the tangent. So let's write all out. Y minus y1, gradient x minus x1, and fill in our values. Again, we have a double negative, so be very careful there with brackets. M was 13. That was 1. And let's simplify. Don't rush too much with these steps either. I know you want to often do it all in your head and skip to the next step, but remember, as soon as you make one little mistake, all the rest of your working is then wrong. So of course you'll get method marks as well, so that's good as well, but don't rush too much, especially in these longer ABC questions. Minus 13, minus 2 from both sides, minus 15. Okay, so that was a lovely question there for, how many marks was that? A nice 4 marks. We found the equation of our tangent. And then just reread the question again. See, did I answer everything? Is there anything that I missed? Did I have to use that equation? No, I just had to find the equation of the tangent and I'm done. So that's good. Please do that every time that you answer a question. When you finish, go back to the question and read it through and say, did I answer everything that they asked of me? Did I make sure to check for any constraints on my answers? Like, have they restricted the domain? Was there another step that I had to do? Please, after every question, you do your little box or you do your underline or whatever signifies that you've ended that question and you go back and read it again. That's probably the best tip I could give you for your whole exam, other than don't forget to charge your calculator. So let's see, we had, look at that, attempt to differentiate. At least one correct term seen gets you a method mark. Lovely. Try every question because you get so many for attempting to do something. Then finding f of 1, so that was just like 2 marks there, attempting to differentiate and getting 13. Then your attempt to find the matching y-coordinate, which was -2, so again, that's an attempt. And then substituting into this formula and arriving. See, you don't actually even have to multiply out when it was 2 marks. You could leave it like that. Thanks. That's probably the best comment I've ever seen. That made my day. Thank you. And I hope you do succeed in maths, and I'm sure you will. So here you don't even have to multiply out. You can get that mark just for that, which is also quite nice. So if you're running out of time, leave that. But sometimes you may need to use the question afterwards, and just in general, it's nice to wrap it up neatly. But just a note that you can leave that. All right, let's try another one. So we have a function defined by x squared minus 10x. The graph of f passes through the point 4 minus 24. So we have our equation and we have a point. Now, why this is lovely, they've been super nice in this question, is we have the x and we have the matching y coordinate. So we don't even have to find the matching y coordinate. So when we write out, let's start from x1, y1, m, so m of tangent, because I see normals going on in there as well. Here I have 4 and minus 24. So that's lovely. They've already done that work for us. So we don't need to go and find our y1. We just need to find our gradient of the tangent. And indeed, that is the first question they ask us. Find the gradient of the tangent to the graph at the point A. Sometimes they might give you more than 1 point. So just make sure that if they say point A, you're really using point A, not point B. So what we need to do is we need to find the derivative. So we have 2x minus 10. And now at the point where x equals 4, so f dash of 4 is 2 times 4 minus 10, which is 8 minus 10, so minus 2. Okay, there we go. The gradient of the tangent is minus 2. Hence, write down the gradient of the normal to the graph. So I can also just put this on my little list under here. My normal then is going to be this with a positive, because that's negative, and flipped over. So if that's 2 over 1, the same as 2 over 1, then this is going to be 1 over 2, positive 1 over 2. So write down the gradient of the normal as 1 over 2. And just a note, when they say write down, and it's 1 mark, write down and 1 mark, you just have to write that number. You don't have to do any working, any fancy showing of anything. Write down is literally write it down. Just pop it in there. So the gradient of the normal to the graph of f at point A. Sorry, that was the wrong. That one, write down. And for 1 mark. So write down. And then we have another one here. Write down the equation of the normal to the graph at point A. So again, that write down 1 mark means just substitute it into that formula. You don't even have to multiply out. So we literally have y minus y1. I should write out the formula, but I'm going to not do that now, but you should. Y minus 24. Was it minus 24? That doesn't, oh yeah, it was. Then our m of the normal, so normal is half, and x minus 4. All right, so that's literally it. Write down. I think the one thing that I would do is simplify that. I would write plus 24. That minus doesn't sit well with me. So that minus, I'd write plus y plus 24. And that was just 1 mark. So don't simplify, don't rearrange, that's fine. Although next question does ask for you to use that equation. So for that reason, it might be nice to simplify this a bit. So let me do that, maybe just at the bottom here. Let's do y plus 24 equals a half x minus 4 times a half, so that's -2. Half of 4 is -2. And then put -24 on the other side. -2 minus 24 gives me -26. So there I've got, that's the equation of my normal. Equation of normal, just to make it very clear for myself. And then they say the normal to the graph of f at point A intersects the graph of f again at a second point. So let's just take that apart there quickly, because they're saying a lot there. The normal to the graph of f at point A, so that's this guy over here, that's the normal to the graph at point A, intersects. Now, when you hear the word intersects, I want you to think, set them equal to each other. Intersects when one graph is equal to another graph. So either you put them equal to each other and you solve for x, or if you're allowed a calculator, plot them both and then see where they intersect. And this is probably a paper 2 question, yeah, based on that kind of question, because we have the squared graph here and a linear graph, so we can plot them on our calculator and see where they overlap. So intersects, the normal intersects the graph of f again, because they've intersected obviously at A, again at a second point B. We need to find the coordinates of B. So because this is a calculator paper, I'm not going to set them equal to each other and solve algebraically, although I could. Just in case it wasn't calculated, this is what it would look like. You have the graph of f was y equals x squared minus 10x. And to find that point, you'd set these two equal to each other. So you'd say x squared minus 10x equals half x minus 26, and you would solve. That would be, and you'd find where the coordinates of x, and that would be where they intersect. So that's how you do it algebraically. But let's do it graphically. So if you have a different calculator and you need help on how to graph on your calculator or do these things, just send me a message on Instagram at Miss IB Maths, and I'll be happy to help you out with that. For now, I'm using the TI Inspire. So let's graph my first one. I have x squared minus 10x. By the way, always use x on your calculator for graphs, even if you have like the variable being t. Your calculator only recognizes the variable of x, unless you've previously defined it, which takes some extra steps. So just always change it to x. All right, that's our x squared minus 10. Then let's go tab to add another one. We can figure out our screen view later. Where's tab? There we go, for our next one. So now we want half x minus 26. So 0.5x minus 26. And let's try make this window a bit better. See fit. Does fit work? I think we need to see a bit more. Okay, let's try minus 20 to 20. That's quite big. Minus 60 to, wow. Just try 60 and see what happens. Okay, there we go. That's way better. So I think I can make this, no, I think that's, yeah, actually, let me make this a little bit smaller. So I think I'm going to take between minus 10 and 15 and between 6 and minus 30. So I want it a little more zoomed in just so I can see what those x coordinates are. So let's say minus 10 and 15. And what did I say there? Minus 30 and 10. Let's try that. Yeah, that's way better. All right, so we can see that they do intersect at 2 points here. So one of these is our point A and one of these is our point B. So let's see, which one do we think is which? We have 4 and minus 24. So that seems like 1, 2, 3, 4. So this seems like point A. But if you're really not sure, you can just find the coordinates of both and then see which one. In fact, let's confirm that that is indeed point A. So we're looking for an intersection. And I need to tell the calculator precisely where that intersection is happening. So that's for my first one. Can you see we have 4 minus 24? That's what we had already. So that's point A. Now we need point B, so the other one. So menu, analyze graph, we want intersection, and I want the second point over there. And that is 6.5 minus 22.75. So my coordinates of B, and note they say coordinates, not just X. When they say coordinates, make sure you write coordinates. So B is 6.5, 6.5 minus 22.75. And there we go. 3 marks just for graphing. How lovely is that? So make sure that you have written it as coordinates, and you don't need to say I use my GDC or I use my calculator. You never, like the used GDC thing is actually not necessary. I know some people say to do this, but trust me, the IB knows if it's paper 2 and you have found that, they know you've used your GDC. It's not like it's a special skill or something. So let's have a look at the mark scheme. Now, yeah, in question A, what was question A even to start with? That was just finding the gradient of the tangent, writing down, etc. So recognizing that you need, so again, this is like an attempt, recognize or attempt, just writing your working. So really, really show your method. If you think of something and you use it to calculate, write it down. All right, then we had just, see, writing down just a half. You don't even have to say m equals a half, just half. Then we had substituting. So see here again, you did not need to multiply it out for that mark. And then here, attempt to find intersection of curve, either graphically or analytically. So you could have, so just having your attempt, you could write out this to show that you know that it means that you're finding the intersection, or a little sketch could get you that method mark. So just that step like I did here of writing the one equation equal to the other. Even though I didn't solve it algebraically, I still wrote down to show that I know that intersection means when they're equal to each other. And then the rest I did on my calculator. And this was just 2 marks for that. 1 mark for showing some kind of recognition that it's when they're equal, and then the coordinate. So 2 lovely marks for that coordinate. And the exact answer is that. So yes, we should round to 3 significant figures. Always, you wouldn't lose a mark for not doing that in this case. This one was not rounded, so we don't need to have 3 significant figures. But this one is 4 currently, so to make it 3 significant figures, it would be 22.8. Remember, it's only 3 significant figures if you've had to round. If it's been an exact answer and no rounding has taken place, it's not then 3 significant figures. That's for things like this. If you have like 22.00512, this to 3 significant figures. So this is a little side quest on significant figures and rounding. Well, I thought of it. This would be 22.0. And that's because there is still something going on here. This is not the exact number 22. So to show that I rounded, I must put 22.0. So a lot of people think, why don't I just write 22? Why do I need 22.0? That doesn't add any value. Well, it shows that all of this is going on in the background, that you did actually round. Because in life, I think, depending on the circumstance, this number is a very different number to 22. Little side quest, a little tangent about rounding and significant figures. Okay, then we had our substituting. Oh no, that's a different question. Oops. That, sorry, it's not meant to be there. Yeah, that's in the wrong place. Anyway, there we go. That was 3 marks. Let's see what other questions. Yeah, this is a fun one. A lovely 16 marks, and it looks quite crazy, but it's actually not. So I want you not to be scared by questions when you see them. You don't ever need to put that you use the GDC. So you need to show that you know what the question is asking. So for example, sorry, I'm just answering a question in the chat that says, when do we need to put that we use the GDC? So in this question, I don't say I use the GDC, but I did write this to show that I know that I'm finding the intersection. So this shows the examiner. I'm finding the intersection, and then I found it on my GDC. So we never have to say that. That's never going to get marks. That's never going to be useful. You just need to, depending on if the marks, like here it was 3 marks, so they probably need to see one more step than just me writing these coordinates, and that step would be showing it's equal. But saying I use GDC is, you can write it, you're not going to lose marks, but it's not going to add anything either. You should show mathematically somehow that you know what the question is asking. All right, so here we have a function. We need to find the derivative. That's starting off nice and gently. So let me work down here maybe. So I'm going to write my function. F of x is equal to 1/3 x cubed. I'm just writing the question so I can see it there. Plus x squared, double check that I copy it down correctly, minus 15x plus 17. Wow. Okay, question A, find the derivative of that function. So that's all right. I'm going to have 3 times 1/3, which is just 1, x take away 1, so just x squared. That goes nice and neat. Plus 2x minus 15. There we go. That's turned into a much nicer thing to work with. Great. Now, the graph of f has horizontal tangents. So do you remember from the beginning when I said horizontal tangents? That's a clue that the gradient, my f dash of x, equals 0. Horizontal tangents, if I think about my graph being like this. However, if I have a horizontal tangent, it's like that, flat. So the gradient is 0. Also at this one, it's flat. Gradient is 0. M is 0. Remember, we are thinking gradient and derivatives. F dash of x is 0 at these 2 points. So this graph also has horizontal tangents at the points where x equals a and x equals b. A is less than b. So we're going to need to find those values of a and b. So these 2 points where the derivative is equal to 0. So I've got my derivative from this question. I just need to set it equal to 0 and find my values of x. So this is working backwards. Instead of them giving me a value of x to find the gradient, I've been given the gradient, like secretly in a clue, to have to work back and find those points of x. So let's set this equal to 0. Was that question B? Yeah, find the value of a and b. So 0 equals x squared plus 2x minus 15. And indeed, when you have 2 points, x equals a and x equals b, that does sound like very much like solving a quadratic. We're going to get 2 solutions, and we're going to need to figure out. And then a was less than b. So that's going to be one little thing. We'll get 2 values, and I know which one a is going to be because a is less. And I know which one b is going to be because it's the bigger one, basically. It's just a scary way of saying that a will be smaller and b will be bigger. So let's factorize quadratic formula, whichever method you like. I think we can factorize this one. Let's see. To make 15, I have 15 and 1, and I have 5 and 3. And to make plus 2x, I need 5 minus 3. So one's positive, one's negative. That's going to give me positive 2. So positive 5 and negative 3. Now x equals minus 5, x equals positive 3. Now, which one of these is A and which one of these is B? Well, A was less than B. So this one's A. A equals minus 5. B equals 3. Because this one was less, remember? And that's how we find A and B. So we know that the points on our graph, if it looks something like this, it probably doesn't. It's a cubic. This is just a graph I made up. But that would be our minus 5, and that would be our point 3. My little graph that I made up is seeming to work with our actual solutions. So now that we've found the value of A and we found the value of B, don't forget to state A equals and B equals, not just X equals. You need to actually, I think there'll be a mark just for A equals this and B equals that. Sketch. Don't be afraid of sketching. Sketch the graph and make sure you know which one you're sketching. Sketching the derivative function, the quadratic. And when they say sketch, that command term is roughly. So if they say sketch, you can do it very much rough. And if they say graph, you need to do it precisely. Those are two different command term words. So sketch. All right, let's draw my graph, and then I have a quadratic. The shape's going to be a quadratic. This is my y-intercept. So it's going to go through the point minus 15, somewhere there. I don't need to be precise because I'm just sketching. Then I've just figured out that my intercepts are at minus 5 and 3, somewhere there. And now I have everything I need to draw my quadratic through. Oh, there we go. Let's just do that, cover it up a little bit. This is not the vertex, by the way. The vertex is somewhere here. This is just the y-intercept because we're at minus 5 and 3. So it's a little bit towards that side. Here you can see in the mark scheme a little bit better. Going through minus 5 and 3 and going through the point minus 15. This was only 1 mark. That was not very generous, but 1 mark. So again, sketch. Don't put your life aims and ambitions into graphing this and taking ages. It is 1 mark. They just want to see your correct intercepts and just correct intercepts really. And the right way around, of course. So then hence explain why the graph of f has a local maximum point at x equals a. So where was x equals a? A was the minus 5. So explain why the graph has a maximum at this point. Now, if we think about, well, firstly, I just want to say that they say hence. Hence explain. When they say hence, that means use the answer before. You might have 1,000,001 reasons to show why the graph has a local maximum. You might do sine tables. You might do the second derivative. But they're saying hence. So you've got to use the graph. And that's only 1 mark. So they don't want you to do any crazy working. So hence explain. Something in the sketch is going to show us. So if we think about there being a maximum on the graph, not this graph, but on the original graph, on f of x, a maximum on f of x, let's say it looks like that. That's saying where the graph is 0, where the gradient is 0. And the graph is going from increasing to decreasing. And what this means on a derivative is it's going from positive to negative. So at this point, we can see that the graph is going from positive above the x-axis to negative here. It crosses at the point x equals 0, which on this graph is our gradient. And it's going from a positive graph down to a negative graph. So we can explain that the graph of f of x, f dash of x, something to this effect, goes from positive to negative at our point x equals minus 5. or a equals -5. So it's going from positive value to a negative value, crossing over where it's equal to 0. So that derivative is showing us what's happening here on this graph. So that's how we know that there's a maximum. For a minimum, it would be opposite. There'd be that point where it's equal to 0, and it's going from negative to increasing to positive. That would be another way you could show it. Then find f dash dash of b. Find the second derivative at the point b, not the point a. At the point b was 3. So let me do this here. Just going to take that out for now. That was d. Find f second derivative at the point b. I'm just going to already write in 3 there. So my second derivative is going to be 2x plus 2. So that was my first derivative, and then I derive it again, so 2x plus 2. And then I substitute for x equals 3. And I get 6 plus 2, which is 8. I think that was just part 1. Hence, again, a hence. Use what you had in the previous question. Hence, use your answer to part D to show, well, here they tell you, that the graph has a local minimum point at x equals b. A local minimum. So what do we know about second derivatives? What do we know about second derivatives and local minimums? Well, we know a fact that if the second derivative at a point is more than 0, basically if it's positive, we have a minimum. You might think positive means maximum, but this is the one where if it's positive, it's a minimum. And if it's negative, if it's less than 0, we have a maximum. So we've just got a positive answer here. This is positive 8. So that means it's more than 0. At our derivative at that point is more than 0, which means we have a minimum. So you can just show that. You can say, since at f dash dash of x is more than 0, we have a minimum. Or f dash dash of 8 is more than 0 is probably a cleaner way to say it. Therefore, f second derivative of 8 is more than 0. Therefore, minimum. That's enough. It was just 1 mark. Okay, the actual point of this question, why it's in this session, we had a little side quest again, went on a little tangent to find minimums and maximums. So that was a little bit of a different topic there. I have done a session on this, I believe, on optimization and max and mins, if you need a bit more help on those. It was optimization and max mins. Went through that in a bit more depth. Okay, this question, we're saving the best for last. It is 5 marks. That's a lot. There's a lot going on here. You really have to think about this one. Okay, the normal. So we're thinking, we were working with tangents, right? Let's see. Here we had horizontal tangents. Remember horizontal tangents. Maybe I'm just going to bring this graph down because that's going to be helpful for visualizing. Don't want to cover it with my screen. So the normal to the graph of f at x equals a and the tangent to the graph of f at x equals b intersect at a certain point. So let me just clean this up of, oh my word. Just take away some things here to make it a little cleaner. So at the point x equals a, remember x equals a was -5. So there's this tangent. There is a normal. So let's think about that. If there's a normal and it's perpendicular, it's got to be vertical, right? So the normal to the graph at x equals a is a vertical line. Now a vertical line has the equation x equals whatever value is at that point, and it's -5. So we don't even have to do anything. The normal to the graph at x equals a is just x equals 5. So normal x equals -5. Nice and easy, because tangent, we had horizontal tangents, so the perpendicular normal would just be a vertical line at -5. Done, easy. There is 5 marks for this question, but there were a few marks in there for recognizing all of those things. That's a lot you had to visualize, and that's quite hard to do if you're not drawing graphs and thinking about your situation. A lot of students struggled with this question when it happened. Then the tangent to the graph at x equals b. The tangent at x equals b. So this was x equals b. That's still a horizontal line, and it has the x coordinates of 3. But remember, this is a horizontal tangent. So horizontal lines, because we have vertical lines like this, have equation of x. And maybe I'll do it in a different color. Let's make our horizontal lines like this. Horizontal lines have the equation y equals just whatever number they are. This point here is the point x. X equals 3. So we need to find out what value of y is it at that point. So we can put this into our original function to find what value of y is occurring at that point. And that will be the equation of our horizontal line. So let's take, we had this one. Let's go back in blue. Maybe I'll just do it from here. So we want f of 3 to find the y coordinate, because here that's 3, we need the y coordinate. And then we know what the equation of that horizontal tangent is. So 1/3 3 to the power of 3 plus 3 to the power of 2 minus 15 to the power of 3 plus 17. And if we simplify, can I cheat and just go and get it from here? I'm going to cheat and not calculate that. All right, we get that it's -10. So you could algebraically solve that, and you would get that that is all equal to -10. Just for the sake of time, I'm being a lazy maths teacher and cheating. But putting that all in or solving it yourself, you would get that -10. So this value here is -10. So what that's saying is that the equation of the horizontal tangent is just y equals -10. And the equation of this line is x equals -5. So if I think of x equals -5, I'm now just going to draw the graph with my just with these two, because we want to find the point where these two intersect. X equals -5 is going to be this line going down here forever and ever and ever. Y equals -10 is going to be this line going here forever and ever and ever and ever. So the point where they intersect, running out of colors, let's go black. The point where they intersect is the point, well, x is -5 and y is -10. There we go. That was 5 marks, the point of P and Q. So sorry, I should say P equals -5 and Q equals -10. So this question was worth 16 marks. There is quite a lot going on in there, but and the questions for sure could be a little bit confusing, could maybe scare you a little bit, especially starting with an equation like that. That doesn't look friendly. But when we found the derivative, it suddenly became a very friendly function. So just take each question really step by step. Don't kind of look at the whole question and think, oh my word, all of that, I don't understand. Take it question by question and try. Just look for keywords like horizontal tangents, things like sketch or hence. Those are all your clues on how to solve things. Look at the mark allocation. So if it's 1 mark, that's like that much time that you're spending on that question. So that means that you are not going to be doing any crazy working out. You don't have to do any massive thinking on that. You just need to use something that you have on your page to work that out. Yeah, and take it step by step. Always small bite chunks, small chunks or small bite sizes. It can be quite overwhelming to look at it all in one go. All right, I am not going to do this question just because we're out of time, but if you do want, I have a whole PDF of many questions like this, which is in the folder. So we have a folder with all the exam notes, all the session notes, so all of these. And then, so it's a folder with session notes, and then also a folder with exam past paper questions per topic of the session I've done. Exam past paper cues. So if you want that, feel free to DM me on Instagram at Miss IB Maths and just send me your email address and I will send you the link to this folder. And then there's the mark schemes as well and more practice questions, including that one. Also, if you are working on your maths and you have a question, or if you are working through something and you don't understand the mark scheme, or you don't understand what you need to do or anything, please feel free to message me. I know this time can be quite stressful and sometimes you just need an answer. So obviously not in the middle of the night, but I'm really happy to help and send solutions. Or like I said, calculated help if you have like one of these. I can let you know how to do it. Also, ChatGPT AI is really good for that. If you're like, how do I find, I don't know, the t-value or something using a TI-84, ChatGPT will give you all the right buttons to press. It's really good for that. Okay, so don't forget that your formulas are in the formula booklet like this. You just have to look for it. It's not in calculus, it's in functions. Then if it asks in this form, highlight that in the question so you don't forget to put it in this form because that's one easy mark at the end. Multiply through fractions before. So let's say I get x plus half y plus, I don't know, 3/2 equals 0. If you end up with that when you've rearranged, you don't want standard form to have any fractions. So they all have denominators of 2. So I need to multiply through every term by 2 to get rid of those denominators, to get rid of those fractions. So then I'll get 2x plus y plus 3 equals 0. Now it's in standard form. This isn't standard form. It can't have any fractions. So just clear fractions by multiplying through. And then we talked about this a bit. Tangents are horizontal, then it has the equation y equals like 3. And if the normal is vertical, then x equals something like 4. So just remember that you're not going to have the whole formula that you need to use like this. Don't forget that for normals, you need to switch and flip. People forget that quite often. And don't forget to find the y coordinate you substitute into f of x, not the derivative, f of x. If you substitute into the derivative with your x value, you're just going to get your gradient again. So f of x for your y, f dash of x for your gradient. Yeah. As usual, we have loads of notes, definitions, worked examples, mistakes to avoid, exam tips in the Learn section of Exam Dojo. So every single section of all of the maths for AISL, for AIHL, for AA, everything is there in these beautiful notes. So I highly recommend using those. They're really, really good. Right, I've now had the class limit. No, what's it called? Never mind. There will be a homework session 15 today for practicing some of these questions. All right, any questions from you? Anything you want to know? Any things that are bothering you or you're not sure about? I'll give you a couple seconds on the chat if you need to type it out. Hope you're feeling good for maths. It's in, next week. It's coming up. And then maybe for some of you, never doing maths again. Oh, that's good to hear. Very good to hear. Thank you for your feedback, by the way. Appreciate that. And yeah, let me know. Message me if you want the session notes or questions, or if you have any questions. All right, I don't think there are any more questions. You're super, super welcome, and possibly see you at the next session later. I think we have 3 more sessions left, 1 this evening and 2 tomorrow. And the one tomorrow is on exam strategy. So just all the tips that I have for timing and how to do your exams will be tomorrow. All right, then. Thank you for joining, and have a lovely Saturday. Bye.